Hi, thank you for choosing this video to watch. I have two new instruments. This one, which I made, and this one, which I bought. And I'll bring you closer and discuss them in detail, and then I'll play one. This is an electronic instrument, obviously, and I've built it into this beautiful red case, which I made myself. And this section is empty right now. I'm going to be filling it with another electronic circuit, but I don't know what yet. But I decided to make it big enough for two. Right now I have a picture of Mary Anning in it, who is a very famous fossilist from the Georgian period. She lived in Lyme Regis. She discovered the first plesiosaurus fossil. So look her up. There's a little link, or here's her name, and here's a link right here. So anyway, I just put her picture there because I didn't want to look at a blank space. This is sort of a rhythm device where there's two clock sources, two sources of pulses, electronic pulses, and these are the outs from these two clock sources, and I've divided this up into 5 sections so I can plug one clock source here, one here, and feed it into different kinds of circuits that'll distribute those pulses in different ways. So here's a list of the logical circuits I have on this board. But the main idea, let's take the OR for example. The main idea is if I send a pulse through one of these cables, which has a frequency of a relatively quick little pulse, and through the other cable I send a rather slow pulse, the circuit that processes those two, let's say that's the circuit, will, if we're talking about the OR, will read the signals, and if it's reading, let's say, 2 signals at the same time, that doesn't satisfy the conditions for this circuit to operate. So it will just make a sort of a blank space. But if it receives this one, where there's a pulse here and no pulse, that satisfies the OR command. Either this one or that one is firing. So it'll send out a little dit on this side. So instead of outputting a constant dit or a constant dit, it will send out something a little more rhythmic, like dit. If you want to learn more about these kinds of circuits and how they operate, I've done a video that I tried to explain it a little bit better, but there's also a website that you can visit, and I'll show it to you right now. The website's called Electronics Tutorials, and if you navigate yourself to the Digital Logic Gates page, you'll find that's the introduction. Go down here and you can see all of the different, they break it down into the different kinds of logic gates you can investigate. So like the one I have set up on the board here called the XOR, the exclusive OR gate, it describes it very clearly on here, and it gives you a little graph, sort of like what I did, but much clearer. If you look in the A and B columns, you see either a 0 or a 1, and the Q is the output. A 1 means there is a pulse, and a 0 means there is no pulse. Very simple. Just to be clear, the XOR works best if there are 3 inputs. I don't have that on my board, but I'll demonstrate with what I have. I'll do a little demo on the other instrument, and then I'll combine them. But this is what they call a steel tongue drum. These could look like tongues, and each one of them is tuned to a different note. Well, I should say, in most of them they are. They try to make it as tuned as possible, but it's difficult to tune these things, I guess. This isn't necessarily tuned perfectly, but you get sort of a high to low. There we go. So this one, it's kind of strange. It should be an 8-tone scale, And it sounds like it's going down in a regular fashion. Can you think of what this one should be? No, that's not what it is. So this is C, basically, and this is something. So now I have been putting incense inside of this recently for my own purposes, but I thought it was kind of interesting when I bonk it, the incense would come out and then the air would slightly ripple as it flows out. So I thought I would video that and play this at the same time.